Number 4 says you were going to launch a ball at 45 degrees. With what muzzle velocity do you have to make it travel 100 meters? So let's draw ourselves a little picture. I don't know what that velocity is. It's got to go 100 meters. I'll break it down into my vertical and horizontal components. So I've got an initial velocity, final, acceleration, time, and distance. Horizontally, velocity, distance, and time. So this is tricky because I'm supposed to break this down into its x and y components. I can't. But whatever this is, since this is a 45, 45, 90 triangle, I don't know what that is and I don't know what that is, but I do know how they're related. They're the same. So you know what? I'm just going to call it, oh boy, V1 for lack of a better. So the initial velocity vertically, V1. Horizontally, the velocity is V1. I don't know what it is. It doesn't matter what letters they are as long as they're the same. This is on Earth. The acceleration is negative 9.80. Let's look at this spot. The velocity right there is 0. I don't know the time. I could solve for the time. I don't know what the time is either because I don't know. I can't just run it through like my other problems. So I don't know time. But here's the deal. Whatever that time is, this one's going to be twice it. 2t. So here's the deal. I have two unknowns, a v1 and a t. v1 and a t. So you know what you have to do is you have to make two equations with two unknowns. This is going to be you have to come up with two equations. I can come up with an equation using all this stuff. Vf equals vi plus at. Vf is 0. Vi is v1 plus negative 9.8 t. I can't solve it because there's two unknowns, but what I'm going to do is make another equation. Velocity is equal to distance over time. So I have velocity. v1 equals the distance, unknown. Oh, crapper. Oh, no, I do know it. It's 100. Sweet. Divided by the time, 2t. So I've got two equations with two unknowns. Man, oh man. So what I'm going to do is probably substitution. I'm looking for v. So I don't want to solve it for t. So I'm going to do a little forward thinking. Because I could literally just take this and put it over there, but that's going to give me the letter t, and I don't want that. So what I'm going to do is a little bit of forward thinking in my manipulation. I'm going to move the 2t over, so I get vi times 2t equals 100. Then I'll move the vi, so 2t equals 100 over v1. This should be a v1, not vi. So then I divide both sides by 2, and I get t is equal to 50 divided by v1. I'm going to stick that bad boy right there. So there's my substitution. 0 equals v1 minus 9.8 times 50 over v1. Holy moly. This is getting crazy. So I'm going to multiply these two things together to try to simplify this. 0 equals v1 minus 9.8 times 50. 490. So 490 over v1. Now I got to solve this for v1. So I'm going to bring this over so I get a negative v1 equals negative 490 over v1. These cancel, so they're both positives. I'm going to multiply the v1 over. So I get v1 squared equals 490. And now I take the square root and I find v1. So 490, take the square root of it, and I get 22.1. That is V1. So this is 22.1. This is 22.1. It's not my V. Remember, now I got to do the Pythagorean theorem. A squared plus B squared equals C squared. And that's my answer. So 22.1 squared plus 22.1 squared. Take the square root of all that. I get 31.3. So my final answer, 31.3 meters per second. That was a crazy, crazy problem. And I did a little bit of forward thinking. Now, you may have done the substitution where you found the t, but then you just got to go back, put the t in and find v1, and then come back. So I did a little bit of, I knew what was going to happen, knowing that ultimately I wanted to find this. So in order to find that, I got to find these. And when I'm over here, it helped me to find the v1 first of all. Crazy problem, but doable.